Hello dear audio wizards and fellow music makers. Tonight we're gonna dive even deeper in clippers. Is there one clipper to rule them all? That's the question. One clipper that is better than everything you have? That was my question. That was my quest, trying to find the ultimate clipper to use in all my mastering sessions. So you may have seen my previous video where I'm doing a shootout between 7 different type of clippers, because obviously clipping is an important part in mastering in the loudness war today. It's maybe one of the best allies, but also your worst enemy when it comes to distortion, harmonics, and a clipper can also really break your track apart. I did this first shootout, and since that last one, I kept searching, I kept reading, I kept trying things out. For those not used to this channel, this video is going to be long. This is why there are chapters. Feel free to jump to the chapters that you are after. And as always, watching this till the end will give you both the technical understanding and play you some audio material to hear and to realize, not to understand with your brain, but to understand with your ears what I'm talking about. After spending hours, days comparing things, listening, eyes closed, A/Bing things, here is my conclusion. Let's have a look at StandardCLIP and put it under the lens. 0 decibels, not oversampled. This is totally flat as frequency response, right? Now, what if I'm oversampling? As soon as I'm oversampling, we see that there is a little drop because this is the anti-aliasing filter happening, right? Times 4 times 32. This feels to stay exactly the same, right? Zoom a bit in that window. It's nothing, right? Because we are at minus 0.8 at 20 kilohertz, and we are flat up to 19. So this is totally inaudible, yet it's there, right? What is happening if I'm changing the filter type, going from linear to minimal phase? This is inducing a lot more of shifts, right? And funnily enough, we have a little dip. Overall level is dropping by 0.5, but then from here on, we have a little boost. If I had to compensate to get back to 0, let me push this a bit. I'm compensating the loss by 0.5 dB of boost. So we see now I have an overall level drop. So the change of filter is changing the overall loudness. This is the first thing that is interesting to notice. And we have this little bump that is arriving, that is appearing. That little bump is getting back at 13 kilohertz, and at 20 we are at minus 3 decibels. So this is changing the color of the sound, and it's depending on the amount of oversampling. But from 32 upwards, it stays the same. No noticeable change, right? And below 16, then it's changing a lot more. You see here the whole curve is starting to lift. You might then go in the export mode and change the order of the filter, and the steeper the order, then you compensate for the loudness, but you get a harder cut. Makes sense, and meaning that there is more phase shift. We're going to talk about phase later on. If we look at the phase here, of course, the steeper the order, the more phase shift we have. Let's get back at the 4-pole. There's just one phase flip happening. Let's reset by default. By default, we are linear phase 4 times. From my experience and my personal taste, I prefer having the minimal phase, even with the drop and with the phase flip. To my ears, it sounded better. Yet, I'm messing up the signal, but ultimately, what I was hearing in most of the cases was better to my ears. What's happening if I'm starting to clip more? I lower the signal. Look at how the curve is changing. Or to be maybe easier, I'm going to push things higher into the clipper by increasing the loudness. See now, this curve is changing a lot. So what we see is actually that the frequency content present here is depending on the amount of clipped signal. If I go back to a linear phase, it is also reacting. So the more I push sound into my clipper, the more I increase this boost. And so maybe, just maybe, we could somehow make up psychoacoustically with a little bump before. This will create a sense of more highs while even dropping higher. And this might be one of the reasons why my ears, while clipping a little bit into the clipper, tend to prefer the sound being with a minimal phase instead of a linear phase. If we now look at harmonics, we see that the oversampling has an impact on the amount of harmonics we are generating. If I'm not oversampling, we have a lot more of harmonics here, a lot more of partial of aliasing happening here, and even stronger here in the fallback, even in the very, very low end, because I'm generating a fundamental. This is the sound I'm generating at 100 Hertz. So we have 3, 5, 7, 9, 11, 30K, etc., etc. But we find back all those in-betweens. And at 24 Hertz, I have like minus 140, to say an easy number. While if I'm oversampling, I'm at minus 160. So we have a difference of 20 decibels of this noise, of this unwanted harmonics generated. Another important thing is that as soon as I start oversampling, let's go to the highest amount to see it properly, I can now play with my filter and choose when I'm starting to apply it. Of course, here I'm too low. I start to lose frequencies here already at 10K. This is not something I want. I want this to be higher. Here, if we look now, if I'm keeping 100%, we'll see now if I'm looking at this, between the oversampled and the not oversampled, it's still working pretty neat. So while keeping this 100% of the source Nyquist frequency, I'm not altering anything, I mean, barely nothing, in the audible range. 0.3 decibels at 15 kilohertz is like very, very transparent. But the harmonics generated by the clipping are much lower, much lower. 20 decibels of difference, and also less of these crappy things in the middle. All those things here tend to be much lower and much less dense. So this is another good reason why oversampling might still be useful while clipping. And how is it working with the harmonics? Does this have an impact? A little bit. So the minimal phase, the linear phase has even quieter results. So normally this should be better. It should be better. I don't have any phase flip. I end up having less of the aliasing, even back below my fundamental. So this should be better, but I don't know. For some reason I don't explain, to be honest. If someone has an explanation, I prefer the minimal phase sound. It might be due to the fact that the filter is inducing pre-ringing. What do I see here is I want a hard clip, but it's not hard clipping exactly. While not oversampling, it's really hard clipping. So the oversampling is creating some kind of soft clipping by itself. Interesting, right? So no matter the mode I choose, we see that the clipping isn't hard anymore as soon as I oversample. It's also interesting. Because I could say, okay, then now I'm going to dial this a little bit up, and I'm pushing the signal in StandardCLIP Pro like this. So now I'm gaining loudness, but leaving this upper part untouched. I'm just getting into soft clipping. This might be a nice tool to push things. Of course, the more you push it, the more harmonics you're generating. If we now get a look at Kclip from Kazrog, there are a few interesting things. If we are keeping it like broadband, we see that the frequency response is the red line is flat until 20k, and we have a little drop, right? As soon as I flip it to 4 bands, look at what's happening. I flip it to 4 bands, what's going on? I have this weird roll-off, starting already at 48 Hz at minus 1.9 decibel. Is oversampling changing that? It isn't, but oversampling is helping hear those irregularities. As soon as I'm times 2, the response is flatter. This is even flatter. Okay, but so at 100 Hz, we are starting already here to dip a bit. So this means that this last band, because this is the last band, is actually dropping in level. So I should compensate, try to make up for that loss. Here I'm flatter, right? So to get something that is somehow flatter with Kclip, you should actually move the lower band really to the extra lows. And here I'm getting something that is pretty close. I have lost 1 decibel at 20 Hz and I've gained 2.9 at 40. This is maybe a little too much, so I can draw back a little bit my gain, something like that. Okay, so here I've lost 0.5, 0.6, 0.5 at 20, and I'm flat until 36. So this is, I would say, a kind of acceptable type of curve. So using Kclip, 50 Hz plus 1.3, 1.2 maybe. I would even like it a little bump because this is enhancing the oomph while removing a little bit of that excessive lows. This is the first thing. Another thing is, if we look now at the phase, what do we see? We have all those crossing points that are making phase flips. So all those crossing points are inducing phase rotations. So my advice would be to really pay attention to phase when you are using it. Long story short, I'm not saying this is not good, because as I said, by using it by ear, there were some cases where the result was more liked to my ears, but it had an impact. And of course, oversampling here has no impact except on the top end. What about harmonics? So pushing sound into the clipper of Kclip, let's look at the total harmonic distortion. Single band not oversampled. We see all this mess in red. Single band oversampled, much lower, right? Higher, much more actually than Kclip. Not oversampled, higher low-end dirt happening. Remember, I'm generating something at 16 kHz, so all this is actually aliasing, right? But when I'm oversampling, weirdly enough, we still have quite a lot of this shit happening here. In the low end, it's a lot quieter, but in the high end, we still have a lot of things to compare things. StandardCLIP not oversampled. They are both pretty similar, right? Red is Kclip. I need to oversample more in StandardCLIP to get the same kind of results, but I can go even higher than with Kclip. But even there, I have more. But in the low end, it's pretty similar, and in the really low, standard is a bit below, whatever. But what now if I'm switching to multiband? This is weird, right? I should expect to have less, because I'm just clipping one band. But actually I have more dirt here in the low end. So the multiband, while clipping heavily, the multiband is inducing even more. And I guess this is due to the fact that I'm clipping a signal and I'm filtering it, because all those bands are filtered. What if I'm not oversampling? Now between oversampled and not oversampled, single band or multiband is kind of similar in terms of harmonics. There are a few differences, of course, there are. There is more density when using single band. The harmonics are more present in the low mid, but in the really low area, it's kind of same, right? Multiband, single band. A bit cleaner, and this is what we would expect, and this is the reason why multiband can be useful while clipping. But the oversampling, a little bit, so it's still helping a bit. This is why, to my ears, this was before doing those tests, just by using the tool, to my ears, Kclip oversampling sounded best. Multiband. If I'm using single band, I prefer using StandardCLIP. If I'm using multiband, I'm using Kclip, but I'm using it oversampled. I loaded here this little effect rack in Ableton, where I have actually my 3 clippers of choice, right? They have been all by default set at a -6 dB of clipping. These are my settings, so 6 time oversampling, minimal phase for the StandardCLIP, Kclip 3 is in multiband mode and it's oversampling 32 times, and Newfangled audio here, boost at +6 decibels, but I have the auto output, so it's compensating the output for the input. So basically I'm driving by default all those clippers by 6 decibels, and I added in front of that a utility tool that is matched to this knob here, where I can boost by +10 dB or -10 dB, and it's compensated at the output, so I have no level changes, but I have the option to push things further into my clipper. Right, so coming back from my first example from the previous test, let's listen how they sound to the kick drum, for example. Let's say this is an acceptable amount of clipping. We read quite a lot yet, but let's say for the example. Let's shift now to Kclip. See what I mean here? There is something that feels already more consistent with the StandardCLIP, but it's a bit harsher. Here there's something a bit phasey with the Kclip, but the distortion happens a less longer time. Let's shift to the Newfangled. Pretty different result here already. I'm not saying there is one better or worse on this case. It might be a question of taste, but now let's listen to some tracks. Let's push it. This is a track from Johan Bonfoy's Sub-Accent. This is going to be released on the Initiate Records. Let's push it. Let's push the track itself a bit more, so we have room to wiggle, to really squash it. You feel how now StandardCLIP here is a lot less tolerant on the low end. Why Kclip? It feels a bit eroded on the low end. We lost the depth of the lows, but it's not harsh, right? Let's remove a bit of the gain. You will feel the low end coming back. I remember I had no volume changes on the bands. This is all by default. This is something where you can start to adjust things, right? Link the input and the output, reduce a bit the input. Makes a lot of difference, right? There the bass is clipped and the volume is really removed. The energy and the load removes. Let's listen to Newfangled. So here we are at some, it's really then a matter of choice, right? Do I prefer something that feels a bit more coherent, but a bit harsher? And then I should remove a bit. Or do I need to squash things more? Then the standard clip is not working at all, but maybe Kclip works, but we lose the depth, the roundness. Newfangled struggles also a bit. Let's try black. Newfangled. In this case, the Kclip works pretty neat, right? This is dirty. Let's check if I oversampled 32. A bit better, but it's not making a huge difference. For the exercise, in one, no oversampled. See, the oversampling is helping a little bit in the cleanliness. Here I have another example which is, I think, really interesting. Tracks from box 5 that is also going to be released on Initiate. See, here the track has a lot of high-end content, not that much lows, and in this case, StandardCLIP is amazing. There it starts to fall apart, right? But wait, now for Newfangled. Oh, I can push a lot further, right? I mean, I'm pushing things too far, really, for it to be audible. I would dial all those gains down a little more, actually way more in mastering situation, but you get the point. Here, see, here for me Kclip is not working. It's the finesse of those pure nearly sine wave type of tones, and this is from Adjust, another Belgian techno producer. Let's start with StandardCLIP. Here I'm already like squashing. Here Kclip for me loses too much of the weight in the lows. It sounds thin. It's not deep anymore, and even the punch, I think this has to do with the different bands. The punch on the kicks, they don't cut through anymore. While StandardCLIP, we hear the extra harshness, right? But it still holds together. And Newfangled is that kind of in between. where I lose a bit of the low end, but I don't feel the phasey aspect of things. Yet I think I prefer the compactness of StandardCLIP in this one. I remove a bit the gain. With less gain, we feel the low end compensation of Newfangled is working less, and this is working better. Compare Newfangled. In this case, with just a little bit of gain. Yeah, I think I prefer Newfangled here, because the low mid is still more present. Yeah, it feels a bit more fuller, a bit warmer, a bit thicker. So this is a good example of why I think there is not one clipper to rule them all, but it's really depending on the audio material and the amount of clipping you are looking for. I was going to say you need it, but you'd never need it. It's what you are looking for. Because there are also other techniques we're going to talk soon about to achieve loudness, which keep the transients really, really neat. My first recommendation here is if you are using StandardCLIP and you are oversampling, you should switch to minimal phase and not leave it by default as a linear phase filter. My practical use of this was that with blinded A/B testing, 9 out of the 10 times or 8 out of the 10 times with StandardCLIP, for example, I preferred the oversampled result. With Kclip from Kazrog, likewise. So I tried this on different clippers, and my global conclusion was, it's my taste. And maybe someone is going to prove me wrong with some other examples. Fine. Then is a question of when are you clipping in your signal? And that's another really big thing, because clipping is sometimes something you want to do more earlier in the chain. For example, if you are using dynamic processors, if you are using nonlinear processes, because you don't want to feed those tools with a signal that is too much dynamic, because then the harmonic result, the transformation of that nonlinearity, will be stronger, right? And so it might be best to shave off a bit of those remaining peaks before entering a saturation, or before entering a compressor or whatever. This being said, because of the nature of how filters work, if you are filtering a signal that has been clipped, the peaks that you have been shaving off, now because of the filter and the phase rotation the filter is inducing, you are messing up that and you can recreate peaks. Alright, let's now have a look at clipping and the impact of filters on clipping. So I'm generating a sine wave at 100 Hz. We see here a proper sine wave. I'm clipping it. I'm creating a kind of square wave. We see the level drop. We see the amount of part of the signal that has been clipped here. What now if I'm dialing an EQ like that? Look at this. Look at this waveform. Look at the peaks I'm creating. Even if I'm below, I'm generating at 100 Hz. I'm filtering at 50, so I'm even below audible frequency, right? This is weird, right? I'm filtering something that isn't there. And yet, I have an increase here of 2 decibels. Without, it's 12, with minus 10, it's 9.6. Why? Because if I go higher, I can get some really nasty peaks happening. Minus 9, 3 decibels, minus 8. So I can get a gain of nearly 5 decibels just because of that filter. 4 or 5 decibels just because of that filter. and I'm fucking up totally my waveform. Why is that? Because while clipping a signal, I'm shaving off a waveform that has a certain shape, where all frequencies are aligned. And when I'm filtering, the filter is inducing phase rotation, so I'm unaligning things, and so I'm changing the place of frequencies into time, and so I'm recreating peaks and troughs, and this is why I'm fucking up my waveform if I want to filter. So long story short, if you need to filter a signal, it's always better to filter it pre-clipper. Play this again. I'll add a second frequency. So the first is 100. I'm generating 350 here. I'm creating intermodulation distortion, which you can see here. I'll show you. You see that actually this isn't there before, and here I have nothing. So this is the difference between the two, and this is the sum between the two. So 100 and 350, I have actually 250, and so I'm creating here 150, 250, 300. So I'm creating all those intermodulation harmonics, intermodulation distortion. And so if I'm filtering this after, I'll even increase the amount of peaks and troughs. I have massive shift, right? I have peaks at -4. I have an increase of 8 decibels. So we first started the example with some sine wave, which was pure signal, but we see that as soon as we have more complex signals, that actually filtering post-clipper is inducing massive changes in loudness. So while if I'm filtering before, now I have something that is clean, properly clipped, right? I have very low induced loudness. See the difference? Filtering post-clipper to pre-clipper. If really I need to filter post-clipper, because in my chain I can't change anything, is shifting two things. One is going from minimal phase to linear phase, and here you see that actually the increase is much quieter. So I have less increase because I have less phase shifts, so I'm less fucking up the signal. That. The other thing is, instead of using filter, if I have no linear phase filters, is instead of using a filter, is actually using a shelf. This has quite a much smoother impact. Ideally, using a shelf in linear phase is the best option. Right. For low cuts, but also for high cuts. I'm messing up my signal a little bit. Well, this analog, see the difference, digital, just a bit above, analog, I'm a lot above. So long story short, if you are using filters, use them pre-clipper and use them linear phase, and use shelf if you have no choice to use them after. That's a good rule of thumb. So it's always better, if you think about the chain, to then maybe filter first, EQ first, filter first, then have the clipping phase, then maybe have some harmonic and some compression aspects of it, and then maybe some final limiter and or clipper, depending, because some tools like Limit 1 or Pro L2 are now doing both in one box. It's clipping and limiter, so whatever. But so thinking about the place in the chain is also something really important. For a long time, I had my clipper just at the end of my session. Then I had it totally at the beginning for those harmonic things. And then I realized that actually when using strong EQ, if you are just touching a little bit, and if you are EQing with linear phase EQs, then the problem is not there at all. But again, to my taste in mastering, except from the particular case of using two cases of using stem separation or using mid-side EQing, where on those cases, I really need and want to use linear phase EQs. On most of the other times, I prefer minimum phase EQs. Why? Because it remains more punch, it keeps more the integrity of the signal. The little pre-ringing the linear phase filters is bringing is usually something that I don't like as a sonic result on my low end. It's making the low end flabby. And it also makes sense if you are removing some energy or boosting some energy in the signal, it's best to do this and then to clip, because you are altering the sonic result. Even forgetting about the whole phase rotation and the peaks you can recreate post clipping, it makes sense to clip a signal that has been EQ'd. Of course, also when using clippers, you want to think about how the clipper is degrading your signal, and this is where, for some reason, people started to develop multiband clippers, because then your clipper is not triggered by the whole spectrum all the time, and so you can manage how much you are pushing some bands. And for example, if you have a track that is heavy bass loaded, you can decide to reduce the amount of bass that is sent to that band, so you are not clipping the low end. Because of the nature of clippers and the harmonics they induce, you want to avoid clipping too much the low end, because then you are creating harmonics that spread across the whole spectrum, creating intermodulation distortion. But also because clipping is inducing odd harmonics. Of course, you are coming from a sine wave to a square wave, so you are just adding odd harmonics. I'm playing here a sine wave. If I'm choosing only the odd harmonics and I'm boosting odd harmonics, look at this part. As soon as I start to add the harmonics, I'm going into a square wave. This is a proper square wave generated by the oscillator itself, and you see we have only odd harmonics. So pushing a sound into a clipper is creating those odd harmonics. Clipping is inducing those harmonics. If you are starting to induce them on the low end, you hear them unfold a lot. If you add harmonics just on the top end, your ear hears less of them. That's one thing. The other thing is that clipping, because of its nature of creating harmonics, works nice on very, very short timed event, on very short transients. It can even help to recreate psychoacoustically the loss of energy. If you have something that is very sharp, very short, but very high peak, you can imagine like spreading something that is intense in one moment in something that is like spread across in frequency. And so you reduce the level, but you spread it in frequency. And so sometimes clipping a bit drums, for example, is something that is increasing the feeling of the hard-hitting aspect of the drums. Then again, if you are working this on a singular track, it's not the same as working on a full mix because of the intermodulation distortion. And then here again, low end is usually decaying for a longer time. Your kicks, your basses, they have a longer decay than your hi-hats, and that all those snappy high frequency content. So if you are creating harmonics on low end, you have more time to hear those harmonics. Because the sound is decaying longer, the clipping phase is happening for a longer time. And so being able to process the different bands with different amounts of clipping allows you to get something that can be more transparent. And this is one of the reasons, for example, why Kclip from Kazrog made it in my top 3 list of clippers. It's not the one I'm using all the time, but it's one that I'm using a lot of time when I have some very heavy bass content, for example. Long story short, my top 3 today as of clipping is still StandardCLIP. I think there is something about the integrity of the signal. There is cohesiveness in there. Of course, if you squash it very, very, very far, then you lose things. But a little bit can help even get some body to the signal. And when using the StandardCLIP, I'm using it always now 16 times oversampled, sometimes 32. I'm comparing if I hear a difference. And I use this with minimal phase filters, with phase rotation filters. Then, if this is not working, if I feel it's too harsh, I like the compactness, but it's too harsh, I might flip to the Kclip, where I can shift between the bands, but sometimes because of those bands there are of course crossing points, and with the crossovers there can be some other things. So sometimes it's working very well, and sometimes I feel that I lose a part of the integrity of the signal. And then my third option of choice would be the Newfangled Elevate plugin. And so between those three, I believe you have always something that is giving you food for work. Last thing I never tried so far, but I'm going to push this with those three now, is to try actually serial limiting. I hope this was helpful and that it will help push your music to new heights. As usual, if you like this content, feel free to like the video, to subscribe to the channel, and to comment if you want to interact with me.